Streams bring functional programming to Java, and they're supported starting in Java 8. So if you have an older version of Java, you're going to have to upgrade to Java 8 to use Java streams. Why would you want to do that? Some of the advantages of streams. First, they'll make you a more efficient Java programmer. You'll see that with very few lines of code, you can actually achieve quite a lot using streams. They make heavy use of Lambda expressions, which are sort of disposable functions. Also, you can enable multi-threaded operations for large data sets very easily using streams, just by changing one word in your streams program in most cases. So a streams pipeline consists of a source, where your data flows out of, followed by 0 or more intermediate operations. So you may have 2, 3, or 4 intermediate operations in a lot of cases, and 1 terminal operation. So let's explain what those are. Now your source is going to stream a stream of elements. That stream of elements can be filtered, it can be sorted, or it can be mapped, or different other series of operations applied to each element. And then it can, at the end, it can be either collected or reduced, or some other terminal operation, but only one terminal operation is performed. So that's how a typical stream looks. A stream source can come from collections, lists, sets, arrays of ints, longs, doubles, strings, whatever. Stream operations are either intermediate or terminal. So intermediate operations like filter, map, and sort, they return a stream so that the next intermediate operation receives a stream. And you can chain multiple intermediate operations because each one is passing a stream on to the next. Terminal operations receive a stream and they can either return void or they can return a non-stream result. So typically a reduction, they could reduce your items to a list, or they may reduce your items to a scalar value or something else. So intermediate operations, like I said, 0 or more intermediate operations are allowed. And order matters. So for large data sets, you would be better off to filter first so that you can reduce the number of elements in the stream before doing a sort or map operation. That's going to improve your performance. And for very large data sets, you should consider using parallel streams so that you can leverage multiple cores of your processor by enabling multi-threading. Some of the intermediate operations include AnyMatch, distinct, where you can actually filter out non-distinct elements, filter, findFirst, map, and flat map, and you can skip elements if you want, and sorted, which is the same as the Java sorted method. You only get one terminal operation. forEach is used to apply the same function to each element. For example, print. Let's say you want to print each element. Collect will save all of the elements into a collection or a list or an array or something. All other options reduce the stream to a single summary element. So count, max, min, reduce, these are all specialized reduce functions. There's also a summaryStatistics that only applies for integers. Now let's look at the code. I have a series of about 15 examples here, and so you can see how streams work and some of the different features and functions that the streams have. And I'm going to save all of this code onto my GitHub site so you can download the code in a single file and test it and run it and use it and see how it works. So the first example is just an integer stream. We're going to create an integer stream using the intStream class and its range function, which gives us a range of integers from 1 to 9 since the 10 is non-inclusive. And then for each item, this is our terminal operation. For each item, we're just going to print it out. We can call the print function within the system.out class using the double colon. And then this last print statement is just a blank line, prints a blank line for us. So let's run that and see how it works. So here we have all the integers 1 through 9 printed out, and again we didn't use a print line, so all of them are printed on the same line. Let's look at the second example. Now the second example uses an integer stream, but we added a skip here. So we're going to skip the first 5 elements of our stream. We should only be printing elements 6 through 9. And then the other thing we did differently in this example is we're using a simple Lambda expression to print the item X that is fed through the stream. X basically is the parameter that is passed into the forEach function. which is a series of integers. And then we're going to print the blank line again. So let's run this and see how it works. So here you can see we printed 6 through 9. We printed each one on a separate line because we used the print line. And you can see what the skip did. We skipped the first 5 elements. Let's look at the third example. So here we again use the int stream to create our stream of objects. However, we put that inside of a print line statement as the parameter for the print line. So what we're going to print is just the sum from range 1 to 5, in other words 1, 2, 3, and 4. It's going to add the sum of those up, and it's going to return that sum to this print line statement, so it prints out only the sum. So let's see how that runs. And you can see it printed out 10. Let's look at example number 4. Example 4 uses the stream.of function, which is really handy because you can stream integers, floating point values, or strings, or even objects. So we're going to pass in as arguments 3 strings, which are names, and then we're going to sort it. We use .sorted. You can also pass in, if you want, your own comparator to the sorted function, and you can also reverse sort if you like. But here we're just going to do a straight alphabetical sort. Then we're going to find the first item using the findFirst function, and then we are going to print out the first item in the list. Let's run that and see how it works. So we print out Alberto. That's the first item in the list when we sort it. So example number 5, we're going to stream from an array. We're going to sort, filter, and then print. So our array is an array of strings, which are names. We're going to use arrays.stream to stream those names. We could also use stream.of if we wanted to, with passing in names as an argument. Here we use arrays.stream instead. And then we're going to filter those. We're going to filter out items only that start with S. So here we're using a Lambda expression that takes in X, which is each name, and then it checks which ones start with S, and it'll pass those on. Then we're going to sort them, and then for each item that passes that sort, we're going to print it out. So let's take a look at how this works. We'll compile and run our code, and we get 3 S names in sorted order. Next, let's take a look at number 6. 6 is going to give us the average of squares of an int array. So we start out with a new int array, 2, 4, 6, 8, and 10. Squares are going to be 4 through 100, right? And we use arrays.stream to stream these integers. And then we're going to use map to map each item, each integer, to its square. So in other words, we're taking in x as an argument to our lambda function, and we're going to return x squared, x times x. Then we take the average of all of those elements. And then if present, we'll print out the average item. Let's run this and see how it works. 44.0. So it prints out a double instead of an integer. Let's take a look at example number 7 now. So in example 7, we're going to stream from a list. We're going to filter those items, and then we're going to print. So here we create a list called people. It's a list of strings. It's the same list of names that we used previously. And then we're going to stream that using people.stream. That starts our stream of names. And then the first thing we're going to do is map them. In our map function, we have to name the class, 2 colons, and then the function that we want to use to map them with. In this case, it's just 2 lowercase. So we're going to convert everything to all lowercase. Next, we're going to filter. We're going to filter out items that start with A. And this is just a simple lambda function here. It takes x, which is the string that's passed in, and then it's going to return x items that start with an A. Here's our terminal operation for each print. So we're going to print each name that's left after the filter. So let's run that and see how it works. So here we have 3 names that start with A, and we can see they're all in lowercase. Next, let's take a look at example number 8. So here we're going to stream rows from a text file. We're going to sort those, we're going to filter them, and then we're going to print what's left. So we create a stream object of strings, and we're going to call that bands. And we're going to use files.lines to create our stream. So files.lines is going to give us a stream of a string for each line of the file. And to do that, we have to pass in an argument of a path, which is the path for the name of our file. And in this case, that's bands.txt. I've used this for a previous video. I'll show you real quick. We just have one band on each line of the file. This is names of music bands. And then we're going to sort them, and we're going to filter out items that are greater than 13 characters. And then we're going to print the items that are left. And lastly, we have to close up bands. So we do bands.close. It's important to close this to prevent memory leaks. So let's run that. And we get 3 bands that have more than 13 characters. Now let's take a look at example number 9. We're still going to use the bands text file and the same list basically to start out. We're going to call it bands2 in this case. We want to filter out items that contain the letters JIT. So we do x.contains. And this is just a string function. X.contains is just a string function. And then we have a collector. So we .collect. We use collectors.toList. And we're going to add all of the ones with JIT into a list. And then we're going to terminate with the semicolon. We're going to terminate that stream operation. We're going to start another one called bands2.forEach. We only have a terminal operation here where we receive an argument x and we print out that item. So we're basically printing out each item that contains letters JIT. So let's run that. And here we just have one item that prints out that contains those letters. Now let's look at example 10. So we're going to stream rows from a CSV file, and we're going to count the good rows. So here we have a file called data.txt. Let me show you that real quick. Here we have A, B, C, D, E, and F, and we can see that one of the rows, E, doesn't have any data. So we want to exclude that one from our stream. So what we're going to do is we're going to read in each row. We're going to split at the commas into an array. So each row will become an array of items. And then we're going to filter out ones that don't have 3 items in that array. So here we do a stream of strings, which is the rows of the file. We're using files.lines to get that stream of rows. We pass in the path as an argument of the text file that we want, data.txt. And then we're going to set our row count equal to the count of this operation here. So when we split these rows, we're going to use the map function. We're going to x.split. X is a string of the row. X.split gives us an array that is split at commas. And then we're going to filter out the ones that don't have 3 items in the array. So using the x.length. And then we count them. Count is our terminal operation that reduces all the data to a single item, an integer count of good rows. And then we print out that count. So let's run that and see how it works. Here we get 5 good rows. So we filtered out the bad row. And then we could use those rows however we wanted in our program. Next, let's take a look at example number 11. In example 11, we're going to stream rows from the same CSV file using the same stream operation, and we're going to call it rows 2 in this case. We're going to split at the commas. We're going to filter out bad rows, and then we want to convert the second item to an integer. So we have integer.parseInt x of 1. So item number 1 in that array, which as you can see in the data file here, item number 1, 12, 17, 14, 23, and 18. We're going to filter out ones that are greater than 15. So there'll probably only be, 3 items in the result. And then we're going to do for each print line. We're going to print those items out, x0, x1, and x2. And then we have to close up rows 2, our stream. We have to close that stream finally. So let's run that and see how it works. Yeah, so we printed out 3 good rows, B, D, and F, where we got good data. And they all have an integer greater than 15 here for the second item. Let's take a look at example number 12. In example 12, we're going to use the same data file. We're going to store the fields into a hash map. So we're going to save this data so that we can use it later. And then we're going to use collect, which uses collectors.toMap. Collectors.toMap has 2 Lambda functions in it. One receives X, our row array, and it returns the first item in that row array. and the other one receives x, our row array, and it parses out the integer value from the 1th item in that row array. And now we have a map. We've added those 2 items to our map for each element of our stream. Then we're going to close this stream, and we're going to use a for loop to print out each element, the key and the value. So let's run that and see how it works. So we print out 3 items, both the key, which is the letter, and the value as an integer. Example number 13 shows you how to use reduction. So we're going to reduce to a sum, which is a little tricky. There is a sum function, but it's only good for some integer streams, so it's pretty hard to use that. Here we're going to use reduce, and we're going to do a sum. So we have a double stream using the stream.of function. We've defined 3 doubles here in 3 different arguments. And we're going to use the reduce function. 0.0 is our starting value. And then we're going to pass in 2 doubles. So we have to declare the type of these 2 parameters. And then we can just add them together. So A and B, where A is actually our running total, and B is the new element that we're passing in. So each time through this stream, basically we're passing in 0 as the starting point, A is the running total, and B is the new item. We add those together, and then when we finally exit, we print out the total. So let's run this and see how it works. Here we get a total of 13.6. Now our last example is number 14, which is reduction to show summary statistics. And this only works for integers. So we have an int stream. We're going to call this int summaryStatistics object. We're going to call it summary. And then we're going to start an int stream of a list of integers here. So this is going to apply a terminal operation of summary statistics to all of this stream of integers. And then we're going to print out the summary because it's assigned to this summaryStatistics object. This shows you a nice summary of data on all of these integers. So let's run that and see how it works. We'll compile that and run it. And you can see our int summaryStatistics object gives us a count. It gives us the sum of the integers, the minimum, the average, and the max. It gives us a nice detailed summary of statistics